People on the back, can you hear me? Fantastic. All right. Good afternoon, everyone, and thank you for coming. And today, we're going to talk about, I know you must have already heard the title here, Building Postgres Apps at Any Scale with Hyperscale Citus. So by raising your hands, can you tell me how many of you are already Postgres users? Overwhelming. How many of you are thinking about Postgres? Very nice. Split crowd. We wanted to gauge how, to what depth we need to go through the session today. So my name is Sunil Kamath, and I lead the product management for open source databases on Azure. And joining me is Craig Kirstens, who's been a part of the Citus team and helped us launch Hyperscale Citus on Azure. And we also have a customer, Matt Stokes, and he has not yet declared whether he's a happy customer or a sad customer. So we'll only know when he comes to stage, and when we ask him some probing questions, perhaps he will leak some interesting insights into his experience. So really looking forward to it. So let's get started and talk about Postgres. So we all know Postgres has become and is becoming more and more popular. And if you look at the industry, the surveys, it's been ranked consistently as the most wanted and also the most loved databases, both by Stack Overflow's 2018 and 2019, as well as being named the Database Management Systems of the Year by DB Engines. And why is Postgres becoming popular? Of course, it starts at the root of being open source, but most importantly, what you see Postgres today is an engineering effort with decades of improvements that have gone into what a Postgres is today. And one of the most foundational differentiation or capability Postgres offers uniquely compared to any other databases, relational databases out there, is its extensibility. That means it offers very diverse set of data types, extensions, whether you want to run your geospatial application, you have a PostGIS extension, or whether you want to go use JSON, JSON-B data types, you have those rich integrated support inside of Postgres. Or you want to use and leverage the different index types. It has a range of index options that you can use as well. Common table expressions, the list goes on and on and on. And that is what has made Postgres to what it is today. And the fact that the community as a whole is innovating and this extensibility network means that it becomes better day by day, year over year. And the core of the Postgres engine, with its decade of engineering investments, is being very, very robust and the most reliable open source database engine out there today. And that is why developers love it, and that is why Microsoft loves it, because Microsoft, it is about meeting developers where they are. And when we see Postgres getting the attention and penetrating into these new application spaces, we went all in to provide a fully managed Postgres service on the Azure platform. And today also, as you may have already heard, we launched Hyperscale Citus. And we will talk about all of these capabilities and what does it really mean to you through the remainder of the session. So we all talked about the awesomeness of Postgres. Now, as you want to use your Postgres into your application, there are multiple ways in which you do that. Number one, foundationally, you start with, perhaps if you're running it on premises, you are running and managing the operating system, you're managing the database, you're managing the entire stack, including the procurement of the hardware and so on. Or you may want to host this in the cloud, and of course, running it on an infrastructure virtual machines is an option as well, where you don't have to, at that time, manage the open source, like the operating system, but you have to manage the database and do the patching of Postgres, patching of the operating system as well, and then also all the other management aspects, monitoring, monitoring, metrics, alerting, et cetera, that you all have to go and build. But what we have done on Azure is providing a fully managed service. And that is not only about automating all the mundane management aspects of patching, backup recovery, disaster recovery, so on and forth, but also more than that, by leveraging the intelligence and leveraging the very reason of being able to support millions and hundreds of thousands of these databases, we can run machine learning and provide intelligent capabilities on top. And that is how we add unique value to Postgres users, by providing and bringing these insights right to the developer's hand so that they can focus on their application and leave the rest for Azure to go and manage. Now, with Azure Database for Postgres, we provide a lot of key features that really adds value to a typical developer. First of all, by virtue of it being fully managed, that means, as I said before, the patching of the databases, the backup recovery, the backup retention, monitoring, alerting, diagnostic and diagnostic logs, et cetera, are all actually included as part of the managed service. We also provide enterprise security on top, with data at rest being encrypted, and also integration with virtual networks so that you can secure access to the database. And then we also offer key developer value in terms of adding intelligent performance on top, where we will actually talk and give you a demo around how these intelligent performance capabilities allow you to be more productive and optimize your database performance without the sweat you would otherwise have to pour in to actually get the best out of your Postgres applications. And then finally, our commitment is around being open and using the community version of Postgres. That means whatever we are providing you to the developers, we are providing all these capabilities without locking you into our platform. It's the same community Postgres that you would otherwise use anywhere else, downloading Postgres from postgres.org. And that commitment provides developers the immense flexibility that they need to use Postgres in the cloud and leverage all its capabilities and innovations. And now, today, we are very happy to launch Hyperscale Citus. And as if you may recall, Microsoft acquired Citus data in early January. And if you know, Citus data is built as an extension to Postgres, makes a single node Postgres and converts it into becoming a distributed Postgres. That means it provides you horizontal scale-out capability by which you can scale your Postgres application to hundreds of nodes, and giving you immense amount of performance and scalability that you cannot achieve anywhere else. And with that introduction, like what we are announcing, Hyperscale Citus is essentially a managed service delivered as a deployment option on top of our current Azure Database Postgres managed service, which means today, if you go into the Azure Database for Postgres, you will be offered two deployment options. One, whether you want to deploy on a single server, or you can deploy it using Hyperscale Citus, in which case you will get instant scalability, and you can scale out your single Postgres application to hundreds of nodes. Now, you may ask, when should I then use single server, or when do you use Hyperscale Citus? And really, the value of Hyperscale is beyond just performance and scale. It is really about enabling you certain types of workload classes that would otherwise simply be impossible for you to run on a single node Postgres. Examples of that include ability to run operational analytics on real-time transactional data. We all know that when you are running a high-throughput transactional applications, when the moment you inject any operational analytical queries, you simply can't scale. And then you are either transactional workload needs to take a hit, or your analytics jobs is not able to catch up with real-time processing. But by virtue of distributing and sharding your database, you are able to get both of these done very, very efficiently. And also, scale not only for either compute or memory and storage, but all of the above. So if you are constrained running your database application on a single node, or you're constrained on running in, like you're constrained on memory resource, or you're constrained on storage resource, or compute or memory or storage, you can now scale out and get the performance you need. And for the single server, if most of your applications, like either be it most transactional applications or geospatial applications like the simple web mobile apps, can all be served using single server model. And you can also move from single to hyperscale as well. So any database that you have, and when the application requires more performance, you can get into hyperscale and get the more more and more efficiency and scalability. So with that, giving you an overall context, an overall introduction of what the managed service of Postgres offers, I would now invite Craig on stage and take you through how would you go about building your Postgres, building your first Postgres apps, and what are some of the key factors that you need to account for as that small application becomes a medium-sized application and then to large applications where Hyperscale Citus would perhaps be the most suitable option. So Craig?
Thank you, Sunil. All right, so giving a little bit more of what we're going to walk through today. In my mind, there's a couple of things you care about in the early stages of building an application, but they really apply to every level. So it's not just about having small data, it's about kind of the 101 level. We're going to fly through that, get through a little bit of the things to when you start to care and worry about performance. When things slow down, when you have a larger amount of data, somewhere around the 10 gig to 100 gig range, then we'll start to look at really large data sets, starting at maybe 100 gigs up to, we have customers in production with the hundreds of terabytes. So how do you really scale a relational database to extremes? I'm going to go ahead and dig right in here. So small data, or the 101 essentially. So Postgres, I saw a number of hands that are using Postgres today, a number of people that are exploring it. Postgres is a really, really rich feature set. And I would say leveraging all of these things early on is really key to getting the most out of your database. If you try to treat Postgres just like you do MariaDB or MySQL or another database, you're going to limit yourself in all that's in the box. So make sure you use everything that it has. The first one is data types. Postgres is very liberal when it comes to supporting new data types. You have a variety of text ones. You have timestamp fields. So on text, don't just use a text. Have a varchar with an appropriate limit if you actually need to bound that. Now the database will actually enforce those constraints like you'd expect. Timestamp, TZ, is actually a wonderful data type that you should always use. So it's a timestamp that preserves the time zone. So as you go from running your application in the East Coast to the West Coast, your application servers are going to have different times. So how do you manage that, right? When you connect from a local client, how does that localize? JSON. I absolutely love the JSON support in Postgres. Now, a dirty little secret, Postgres got JSON support in 9.2, and everyone was excited about it. I talked about it a lot, was really excited. All we did within Postgres, though, was validate the JSON and put it into a text field. So we were kind of cheating at that point. Now, this is really nice if you have something like API data coming in, because it preserves all the white space, because it's just thrown into a text field. But if you're actually doing things with JSON, what you probably want is JSON-B. JSON-B is a binary representation of JSON on disk, so you can index into it, query into it. Most application frameworks will use it. So if you're having kind of a mixed workload where you've got a bunch of relational data and some non-relational, JSON-B is a really nice data type. Each has their place, but make sure you kind of use them correctly. Constraints. This is one where every time I come across an application that doesn't have constraints and says, yeah, our data's good, we have application checks on everything, we don't have bad data, and they start to migrate systems from old system to a new system or add constraints in, they're like, how do I have two orders from the same person, one deleted, one canceled, and one still active on the exact same date, exact same time? Constraints are really, really useful to ensure good data integrity. They allow you, when you delete a user, to cascade that down and delete all the records related to that user. So really useful in the state that we're in of data security and privacy, that when data is deleted, it's actually deleted all the way through the system. Invest early. If you don't put constraints into your system on day one, and you come back when you're at 10 gigs, 100 gigs, you've probably got some data issues there. And now you have the hard thing of how do I clean that up? Set up your tools. Quick show of hands. How many people here use a CLI? Few hands. How many people are more like graphical interface folks?
Nobody.
Oh, wow, okay. Cool, so let's see if I swap over here. Perfect. So I'm a big CLI guy, but we're going to walk through kind of both options. So PSQL is the default editor that ships with Postgres. I can do some really nice things if I just start to spend a little bit of time mastering it. I'll blow that up a little bit more. So first, really quickly, I can describe my database and describe my tables. I can do \d to say, what does the schema look like? And if you're interested, I'll be doing a live talk tech session on Wednesday where I'm just going to be walking through some of this live SQL, et cetera, planning out an upcoming Disney World trip where I'm looking at the shortest ride time. So if you're interested in like fun with SQL, come join that later on. \x auto is really, really handy. This is going to auto format the output of my query so that it's formatted cleanly on my screen. So if I do something like select star from GitHub events, and I just get one of these, if you can see right here, I have the column on the left and the value on the right, so that it's automatically nicely formatted based on the width of my screen. But if I come back in here and change this query a bit and say, give me only event ID and repo ID, you can see it's going to be vertical, like it normally is. So now I'm actually getting clean, nice, auto-formatted text without having to do anything. And I can set all of this, I can also set up from my editor. So my default editor is Vim. I can hop in here to edit my query, change something about it. Maybe I only want event ID. Save this, and it'll automatically run. So let's see, if I swap back over here 1 second. So all of this I can set up in a PSQL-RC file. So I spend a lot of time in my editor. PSQL-RC, just like a bash RC or a Vim RC, is super useful. So you can set all of these settings. You can name queries and save them, rerun them, all of this directly in the CLI. So really, really useful and powerful that I can now work in my native spot really powerfully. In the early stages, I would really recommend setting this up then, so that when you're in production with a large data set and something's on fire, you already are familiar with your tools. So the other one I'm going to drill into is Azure Data Studio. So we open sourced Azure Data Studio support for Postgres just about a month ago. And let's hop over here. So a big kind of knock I hear against the Postgres community is, what's the best graphical editor out there? And for a little while, I didn't have a good answer. Now I have a much better answer. So Azure Data Studio here, I have a nice graphical interface like I'd expect for managing and working with my database. I can have server groups right here, which is really nice, so I can actually see, highlight, and color code these of like, what is production? Like red, be careful. What is my dev? I can go ahead and connect here and explore my database. I've got a couple here. I can run a new query. And I'm going to get some nice tab completion here. Let's try a different table. So if I'm looking at wait times for the ride Soarin' at Disney, I can say, OK, rerun this and see what was the wait time at this various time. I can actually go and now chart this and see over some period of time, how did the wait go up or down, really nicely directly integrated with where I want to work. So in the early stages, it's pretty easy. You've got a small amount of data. It's really about getting the basics right. Get your data types right. Use them very liberally. Use the right data type for the right job. Spend time with your tools. Don't go and try to figure out your editor setup when you've got a large production website. Do it in development. Spend time with it. Where are you going to live and breathe when you're working with your database? Make sure you have constraints in place on day one. I can't stress that enough. If you don't have them in place, then you're going to run into surprises later on with data integrity. In the early stages, it's pretty easy. As you start to grow, though, that's where things get a little more complicated. Now you've got 10 gigs of data. Things are slowing down. You've got new customers coming on board every day. I get the question all the time of like, what do I need to pay attention to? What's important in terms of monitoring my database? I know things are slow, and I don't know why. So the number one thing you can do to take care of your database is give it memory. Postgres is going to be really good at keeping frequently accessed data in memory. And the biggest thing to do is, what is my cache hit ratio? Which is, how often am I returning data from in memory versus going to disk? As soon as you start going to disk, your performance is going to fall off a cliff. You're going to go from something being like 1 millisecond down to hundreds of milliseconds is when you're scanning disk. So this really, really nice simple query is going to give us back a number that's a really high-level health check of our database. So this is saying, hey, 99% of the time, I'm returning stuff from in-memory versus going to disk. This is something I keep saved, and when I come to a new database, it's one of the first things I look at. We can also look at the same thing for indexes. How often am I using indexes when I'm querying things? If I've got a really targeted set of queries from my application, I want to give me all events for user ID 123, I should probably have an index on user ID 123 and be using that index really frequently. Now, this is going to give me something that looks a little different, and I've got to do a little more work with. So this is going to give me the number of rows in the table and the percentage of time an index was used against that table. So here I'm looking at like an events table. I can see I don't have any indexes, or I have really bad ones. But I've got, let's see, 700,000 rows in the table. So this would be a really good candidate to come in, add an index, and I'm going to get much, much better performance from my application. Really rough rule of thumb. And there is no kind of perfect answer for this. It varies based on application. But I'd recommend for most applications I see that are serving end users on the web, you want to target a cache hit ratio of 99% or higher. As soon as you go from something like 99% to 98%, your performance is going to fall off a cliff. So I check this on a weekly basis on any production application I'm running to say, hey, how are things? Index hit ratio, you may also want it really, really high at 99%. It kind of varies. If you have a lot of reports within your application, it may be a little lower. If you're doing a lot of really targeted lookups, you want it to be high, like 99% as well. And so within Azure Data Studio, I actually have a notebook, which will have a blog post, I think, coming out to a nice surprise in a week or so that walks through all this. So I can have all these queries saved directly within Azure Data Studio. Anytime I connect to a new database, it's a matter of just clicking run. And I can do a lot more with this than just cache hit. I can monitor bloat to see if I need to tune auto vacuum. I can monitor unused indexes, really about everything I want. So it's nice, a nice toolbook for me to have everything there. All right, so at the medium level, you're looking at cache hit ratio. You're looking at your index utilization. And then we say, OK, I don't have a lot of indexes. I need to go and add some to speed things up. Postgres has a really, really rich set of indexes. About every year, it gets a new index type. Most databases have one or two. Most databases, when you do create index, you get a B-tree index. If you're like me, when you read through like the white papers, the docs on Postgres on these indexes, this is your reaction. Like I talk to committers and I have them explain, and they basically dumbed it down to my level so that I can finally understand it. This is my best attempt of when you want each of these. So a B-tree is usually what you want for basic data types. It's what you learned about in CS school. Standard text numbers, when you're looking things up by user ID, some exact match, a B-tree is probably what you want. For the most part, you don't have to think too hard on if you're using really basic data types. You just want to use create index. It'll use a B-tree index. Gen index, or generalized inverted index. So this is a slight oversimplification, but I've found it's right 98% of the time. Gen index you want to use when you have multiple values within the same column. So if you think like a JSON document, if you think about arrays where you've got multiple values, that's usually what you want. If you're using JSONB, gen indexes are wonderful. They'll index all the keys and values, so as you start to query into your JSON objects, they're fully indexed for you. You don't have to do any extra work. Gist indexes, this is a little hard to describe, but useful when you have values that can overlap between rows. So if you think of things like parts of speech, if I've got a sentence and maybe the and appear a bunch of times, well, it appears a bunch of times in different rows. So if I'm doing kind of full text search, I want to find where this matches between different rows. Also for like overlapping geospatial shapes. If I've got a bunch of circles and polygons and I want to find where a point is exactly within those shapes, just index is really useful. So if you're doing things with full text search, PostGIS, just indexes are really useful. For the others, SPGIST, I've asked the core developers, every time I see them, I ask them to explain it to me, and the only thing I have learned it's good for is phone numbers. So if you're dealing with phone numbers, SPGIST. Brin is really useful for really, really large data sets. So if you have hundreds of millions of rows that naturally cluster together, Brin can be really, really useful here.
Thank you, Craig. But before I leave Craig to go, I have a couple of questions for him, which I think is controversial. I know Craig said create constraints, right? How many of you have created constraints and suffered the performance impact to ultimately disable constraints? Have anybody here done that? Okay, good. What is your recommendation for that? Like how much do you think is the performance overhead for these constraints? Because as the scale or the relationships grow, that's one of the significant pain points many database applications face.
Yep. Yeah, no, it's definitely a balancing act, right? Because every constraint you add is basically a new index, a new check, which slows things down. I actually once wrote a blog post jokingly that to make everything fast, you should index every column within your database, because that speeds things up, right? And then you can do a rate of 1 insert per minute at that point. But it's a balance act. So it's something you want to continually monitor. I definitely say start early on, because you want that data integrity. As you scale, things may change.
Right. I mean, that's the key point. It's always a balance point. I mean, you can go extreme, one extreme, create all the foreign key constraints, and then take the performance penalty. But then there are some constraints that are always good to have. For example, defining a not null column is not null. Those are very useful, and where you would have potentially data integrity challenges down the road. And the second one that Craig and I did not agree with coming into this session was the index hit ratio, right? He said index hit ratio less than 95% is okay, and I was debating it should always be 99% and above.
And so I think the balance there is with all things databases, it depends. If you've got a lot of reporting, your index hit ratio is going to be much lower. If you have zero reporting, it should be much higher.
Yes, so I mean, that's the big caveat. It depends, and the performance every answer to a performance problem is always it depends. And also, most importantly, that I've come across in many scenarios is you add all indexes. When you do the explain, you see that the query is taking an index, but still the hit ratios are low. What else? What would you do, right? Simple answer: add more memory. Okay, so. Craig talked about range of hit ratios and constraints and all the good stuff, right? Now, performance tuning can still be an art. It is still an art to many, right? And that's why when it becomes an art, that's where AI, ML, et cetera, all come to play, because that will allow us to find the needle in that haystack and allow us to provide better tuning and better insights around what is happening around on the database performance. And that is where we have invested most in providing those capabilities in the form of a managed service, and to improve the developer productivity and bring some science via leveraging AI and ML to provide to discover patterns and then come up with concrete recommendations. Now, these recommendations come in several forms. Number one, we have created what we call as the query store. Postgres has hundreds of views that you can collect data, and most of the time it is a point-in-time snapshot of that data. That is, suppose say you run a query, take the snapshot, then you know exactly what happened before and after, right? And that's how you go iteratively understanding the problems. But then, if you are trying to solve different problems, you have to navigate through these dozens or hundreds of these views and then be able to gather insights into what exactly is happening or what is actually the underlying root cause for the performance issue you're seeing. And that is what we did with Query Store. By leveraging the Postgres views and innovating on top, what we did was to provide you a single database stored inline to your Postgres instance, wealth of all the data that is going on or all the metrics that you would ever care for under one database, and then most importantly, storing it in time series format. So think about this. Your application user comes to you and says, I had a performance problem a week ago. What happened? Tell me the root cause. I need to answer my end customer. What are the ways in which you would do that? You will say, OK, reproduce me the problem. I will go investigate it. And that's not an answer many times. And you would want to, and that's what Query Store actually allows you to do, is to time travel back. Today, currently up to 30 days of data is stored in this Query Store. And you can write through the power of SQL, like pSQL, party on that data and wealth of information and insights that's available to you to actually get to the root cause. Now, for some select scenarios, what we have also done is provide you with rich graphical user interface and providing those insights in a visualized format for you to be able to reason over wait stats or queries waiting for disk read, for reads from data from the storage, so that you can investigate, like as Craig was pointing out, whether your buffer pool hit ratio is poor, or whether you are running out of memory on your instance, or your storage I/O throughput is insufficient to handle the workload volume. So we would give you a rich visualization so that you can reason over that data and then get to the root cause in a very, very optimal fashion. So now let me turn back to Craig so that he can demonstrate to you how actually the intelligent performance capabilities actually work.
Yeah, so I walked through all of, how do you pay attention to your cache hit ratio? How do you pay attention to your indexes and when you need to add them? And I spent a lot of time with people, giving them advice and guidance on how to optimize their applications. The reality is, with kind of Query Performance Insight, I'm out of a job now because I don't need to do that. It just does it for me. So here I've actually got a database that I've been loading some data in that I'm going to walk through on Wednesday in more detail. But here at a really high level, I can actually just come in and see where's time being spent. As Sunil mentioned, I can drill this into the last hour. I can see I was spending a lot of time loading up my GitHub event data, running some queries. So I can start to look at a really high level of where is time being spent, but I can also get more granular kind of recommendations bubbled right up to me. So I can see that queries are running slow, they're using sequential scans, and they need an index. So here I can see that these 4 indexes all may be useful, but this one on user ID would be a medium level impact because I'm running this query really frequently. So really nice that these high level kind of recommendations can be bubbled up to me right away without really having to be an expert on the database. But if I do want to be even more expert, as Sunil mentioned, I can hop over to Query Store, right? And Query Store has all the raw data. So I can query it and say, let me see the number of times I've had a call, calculate the cache hit ratio, and I can do this on a per query basis. So not just at an aggregate level, but on a really, really granular query level of how many times did I run this query, how many times was it going to disk versus memory. So if I think, hey, I know better than the query recommendations that are coming to me, I can dig into the raw data and sanity check these. All right, so a few other things for the medium level. Schema migrations. This is one that I see people get burned on as they go from a small database to a medium one. When you've got a really small database and you add a new column, you usually say, hey, give me a new default for this. I don't want it to be null. I want it to start at now or as of some other value. On a small database, it's going to be really fast. Because what's going to happen is going to rewrite the table, but that table is really small. As your table grows, and you now start to run a migration and rewrite this table, what you've actually done is caused a kind of production brownout where you can't write or read from that table while this is happening, which is generally not good. Following this process of allowing nulls, starting to backfill the old data, and then set a null constraint is a really useful process if you're running older versions of Postgres. Now in Postgres 11, all this goes away and it's solved and just works for you, but are really good to do on older versions of Postgres. Highly recommend it in getting into this practice early. Otherwise, you're going to accidentally run into kind of a production brownout. Another thing to start paying attention to. When you're really small, you've only got a few users. As you grow, though, you've got a lot more users. You've got more web servers connecting and hitting your database. And you start to want to watch your connection limits in Postgres. So Postgres is OK about managing connections, but every connection you make to your database is going to consume about 10 megs of memory. We talked about memory being really valuable to the database. I want to have as much memory free running queries as I can. So here what I'm going to want to watch is the idle versus active connections. There's a query you can search for and find that'll show you how many are idle, how many are active. You can also get recommendations directly within your Azure portal on, hey, should you add connection pooling? If you do need to add it, there's a couple different layers. One is the application layer. The other is kind of at the database layer with PG Bouncer. Highly recommended if you've got something like 100 idle connections. It's basically going to take those idle connections down to 0 and only let the active ones come through to your database.
And in fact, it's a very common pattern, especially if you're developing a modern applications through a microservices-based architecture where you have these multiple microservices representing the different application components talking to a centralized database. And if you have each of these microservices open one-to-n connections, it can really storm and potentially negatively impact your database. And therefore, connection pooling becomes a necessity to allow you to enable the Postgres database to scale.
So as you're continuing to scale, you're optimizing your indexes. We've added some connection pooling. You're watching your cache hit ratio, and as it drops down, what do? You go get a bigger box, right? That's the easiest thing to do to keep a database performant. Then at some sort, you're adding a read replica so that your reporting queries aren't hitting production, right? You've got your main application, then you've got separate reporting read replicas, maybe a caching layer in the front. But at a certain point, there's a question of how do you keep scaling, right? And this is when we get to the large data point. This is maybe around 100 gigs, maybe a little over. I think it varies. Sometimes it's a terabyte.
Yeah, that's also another question that Craig and I usually debate, whether should the scaling be defined in terms of the storage size? Is it just the database size, or is it connections? Is it memory, transaction latency, throughput? It's actually all of the above. So yes, we trivialize and talk in terms of the raw database size, but that's why let's land into like scaling and achieving high performance. So before I dig into explaining the hyperscale capability, I want to spend maybe a few seconds talking about what hyperscale really stands for. So hyperscale is a terminology. It's a branding. It's a bucketing of everything that has got to do with performance and scale for relational databases within the Azure-supported database engines. And that includes SQL, MySQL, Postgres, MariaDB, et cetera, all the different relational database engines we support today on the platform. And we are talking about every dimension of scalability, be it CPU, memory, or storage. And all of these are built in a cloud-native fashion. They are optimized for cloud-native applications. And the different engines are optimized and provide different levels of scaling. SQL database, you heard this morning, offers a storage scale-out with Hyperscale. Whereas with Postgres and with Hyperscale Citus, what we are providing is scalability across compute, storage, and memory. That means you can scale out your single node database across hundreds of nodes and get better performance, and most importantly, get better performance at scale. Because there are multiple ways to achieving scale. You can still say that, hey, my application, I moved from 100 concurrent users to 200 concurrent users, yet scale. But if the performance latency from going from 100 connections to 200 connections degraded by 2x, that's not necessarily what we call or refer to as performance at scale. At performance at scale, you add users, your database grows, your query throughput grows, and your latency either remains constant or rarely regresses. So with Hyperscale Citus, what we provide you is a horizontal scale out of your single node Postgres so that you never have to worry about scaling your Postgres database anymore. As your database grows, you keep adding nodes and you scale out. And today, you can scale out to hundreds of nodes. But theoretically, there is no upper bound in terms of the limits that you can scale this database up to. It's just a limit that we kind of have it today, but you can scale it to infinite. And most importantly, another important point that to note here is this Hyperscale Citus, which is built around with the Citus data technology, the Citus extension, which is also available as open source. That means with Azure, we provide you a fully managed experience for this Citus scale-out capability, but you can also use the open source extension to try it out and test it on your own machines, on premises or anywhere else. And therefore, the solution offers you fully, and therefore the solution is fully open to you, and that means you don't have to fear about the lock-in with this technology. So let Craig come and explain under the hoods how Citus actually does its magic to scale out and make Postgres distributed.
Perfect, thank you, Sunil. So under the covers, what we're doing is sharding your data for you. It's following the same best practices that you'd look up for someone like Instagram or Google or Facebook, taking care and sharding that into multiple physical tables under the covers. So as you can see here, if we had 3 worker nodes, we'd be distributing a table across multiple nodes, splitting that up into smaller pieces. As a query comes in, Citus has multiple different executors that are going to change the query on the fly, send it to the appropriate node. So if I'm doing a really quick insert, that's going to a single node. If I'm doing a really quick lookup, say for one user, that's going to a single node. But I'm also supporting things like if I want to do a count of all the events within the system, that's essentially going to farm that out and do a map reduce under the covers for you. So you're going to get a count from each of those individual shards, bring that back to your coordinator that's going to do the final aggregation. But I think probably more fun than walking through it here might be to actually show it. So what I've got here in my Azure Data Studio notebook is a couple of tables. So a GitHub events table and a GitHub users table. GitHub is nice enough to make a lot of their data open source, which makes it really easy for me to build a demo on. So I'm going to go ahead and run this, and it should create a couple of tables for me. At this point, I've just created 2 Postgres tables, nothing kind of crazy or special. Where the magic comes in down here is this create distributed table. So these are special new functions you get with Hyperscale. These are going to say shard my events table and my users table both by user ID. This is really nice because it's automatically going to co-locate that together. So when I join on it, it's going to be pushed down to the local node. So I don't have to send a lot of data over the wire. So I'm going to go ahead and run this. Perfect. And then what I'm going to do is copy this and start to load up some data over here. So in the background, I'm going to let that run. That'll take a minute or 2. To give you a look of kind of in the meantime, while that's loading, I'm loading about 1 million events. It's over the conference Wi-Fi, so everyone turn off your computers right now. But to give you kind of a look of what it actually looks like under the covers. So under the covers, right, we've got all these different tables. This GitHub events table underscore basically 1, 2, 3, 4, 6, 7, 8, etc. We're splitting those up across multiple nodes. So I think a big kind of aha moment for a lot of people is that we define a large number of shards up front. So a shard isn't tied to a node. You have multiple shards contained within a single node. Now this is really nice later on because as I need to scale and add nodes, I don't have to go and invasively break up a table. I just say, hey, I've got 16 GitHub events on one node. If I want to add a node, I'm going to take 8 of those tables and just online move them over to the other node in a completely online fashion. of course, the conference Wi-Fi is still running. I'll get a couple of these things ready as well. Oh, actually, there we go. Perfect timing. So it took us about a minute to load up a little over 1 million events. Users is a good bit smaller. It's around, let's see, 200,000, so not so bad. Now I can come in here and actually create some indexes as well. And so creating an index looks just like it is against standard Postgres. The difference is this is automatically going to go and create an index on each of those smaller shards. So I didn't have to think any differently, work any differently. If I come back over here to my application, right, and describe my tables, I can see it's just a standard GitHub events table, a GitHub users table. I can query it and just get one back. I can do a select count star here as well. So how many events do I have? Oh, it looks like I only loaded about 100,000. And I can run this explain plan also. And here on the explain plan, it's really interesting because what you can see is you see this parallelization in work. You can see that this is a task 1 of 32. It means I ran 32 smaller counts. So if I have a cluster with 32 cores, I'm actually going to be 32 times faster than what I would get on a single node instance. So I've actually seen in cases, where Hyperscale Citus will be 100x faster than what you would get on a single node database because we're splitting things up. I really like the idea of when I have a really large database, going back to when it was really small, like when it was 1 gigabyte and there were no worries. I didn't worry about vacuum. I didn't worry about indexes. I didn't worry about bloat. That's essentially what I've got here. Now I've got a bunch of smaller tables, a bunch of smaller databases, which makes all of the management much easier. I can run more advanced queries as well. So if I come down here, I can do things like join the GitHub events and users. So if I want to see which users were the most active across all the repos, it just works, right? It's standard SQL. I didn't have to do anything different. I didn't have to tell it about eventual consistency because it's fully consistent. It's a relational database. It just works directly from my application. All right, and we walked through this. So yeah, to your application, still just looks like a single node database. I didn't have to teach it about all that complexity under the covers. That's been abstracted away from you.
Now, is that cool? Yes? Thank you. So this capability of Hyperscale Citus is being launched in preview today. And please, we request you to go try it out, give us feedback. We have it in preview right now so that we can hear and listen from your feedback and then can continue to improve it and enhance it over a period of time, and can't wait to make this generally available soon. So now, early on I said I'm going to invite Matt Stokes to the stage. Come on, Matt. He's a good guy. I don't know, good or bad, I guess time will tell. He hasn't disclosed yet what he's going to talk about. But why don't you first introduce yourself, Matt, and your role at ASB Bank.
Okay, so my name's Matt. Hi, everybody. So ASB is a bank in New Zealand. You might have realized I've got an accent. And what I do is we've incubated an ISV outside the bank along with our parent bank, CBA. So it's a product called Vonto, which is on the shirt. And it's a business analytics tool for small business. So business owners and stuff like that who aren't looking at data, we put something together for them.
Very nice. And you did tell me that you are very jet lagged.
I'm mildly jet lagged. It's a 13-hour flight. So yeah. Perfect.
So Matt, tell us about how did you get into Postgres?
How do we get into Postgres? Look, Postgres was our database of choice. It was a relationship database that we used because it was open source. We had a lot of Postgres developers, and yeah, that's where the route that we wanted to go down. That's where we were. So.
Okay, so you started your journey with Postgres. Then tell us what happened.
Yeah, so it's a bit of an interesting story. So we started with Postgres. We launched our application, and we had what I call a quality problem. So we had too many users sign up in too short a period of time. We're too successful. We actually had to pull the advertising.
That sounds like the perfect problem, right? That's what everyone wants.
Yeah, it's a quality problem. Not a bad problem to have, but it was definitely a problem that we had. So we were panicking. So a normal business owner signing up to our application, we wanted to kind of wow and impress them within 2 minutes of signing up to provide an insight into the business that they wouldn't have seen. It was taking 40 minutes, and it was getting worse and worse. And it didn't go from 2 minutes to 3 minutes to 5 minutes. It went from 2 minutes to 40 minutes. So we were panicking. And panicking and some Google research and late nights with the developers and the DevOps team. We couldn't figure out what was wrong. We eventually figured out our IOPS was locking up a table, and we stumbled across Hyperscale Citus, and this was the answer to our prayers.
Interesting. So you launch your application with a single node Postgres, and initially the response times are good. The onboarding time is within your acceptable.
Yeah. So we had a definite target of 2 minutes.
2 minutes.
Yep.
2 minutes was your threshold.
Yep.
Okay. And then
It sounds like they fell off a cliff, like we were talking about earlier. Performance doesn't just get a little worse.
right, and I'm almost at the border here to fall off the cliff here as well.
Can you illustrate that for us?
Health and safety issue. Yeah, no, it was. We fell off a cliff. It's because you had peaks and customers all coming on at one certain time, but it was a cliff. It wasn't acceptable to me as a product owner or chief product officer to keep going like that. No business is going to want to come back to our application if we're waiting 40 minutes to show them something.
So did you regret your choice of Postgres?
I wouldn't say I regretted it. I was having many sleepless nights while we tried to figure something out, but we'll stick with Postgres now after Hyperscale Citus.
But what were the options on the, what are the options you were working with leading to Citus?
So Citus was our option A, but with a whole lot of devs around, we had a couple of and a whole lot of paranoid people, one of them sitting in the front of the audience. We had a couple of other options. So we looked at Aurora. So that could have we could have duplicated a whole lot of the database and gone that way as well. When I looked at it and when we talked it through, that's only going to last us 3 or 4 months, and that's not a scalable solution for me. I'm just going to be back in the same place in 3 or 4 months' time. The other solution is we just re-architect the whole thing. So I pull out of the market altogether and look to re-architect because of the amount of data that we're getting up front. And that probably wasn't really that palatable to me either, but that was option C. Unfortunately, we didn't have to go down either option B or option C. I can't explain to you, it was 2 sprints, so that was 4 weeks for us. And we told all our customers we're going down for the weekend for maintenance, and we had planned for Saturday and Sunday to be out, and hopefully back up and running on Monday. By 10 o'clock on Saturday morning, we were up and running again. It was seamless. It was
2 sprints.
2 sprints.
And each sprint is 3 weeks?
2 weeks.
2 weeks. So
2 weeks.
in 4 weeks.
In 4 weeks.
You discover and you go to production.
Yeah.
Brave. Very brave.
Well, yeah. It's that's amazing. And the other thing is, I can't. The actual technology here to have a relationship database that. So we're on 6 nodes at the moment. It's not a huge amount, but that's what we needed. But at one node, it just didn't work, right? So a singular Postgres database didn't work for us. The fact that we can just migrate across, bang in some extra nodes if we need to now, it's genius.
Fantastic. So now that you have discovered Hyperscale Citus, what do you see as kind of the next big thing that you would want to do with it?
Yeah, so the architecture of the product's actually split up into a number of databases, with the Hyperscale Citus being on our biggest database at the moment. A lot of the smaller Postgres databases we haven't migrated across to Citus, to Hyperscale Citus, and that's what we'll look to do. We're scaling into Australia as well, so like I said, ASB's a New Zealand bank. We're owned by a bigger Australian bank. They loved what we've done so much that they want us to bring it across to Australia. And that's a much bigger market for us. So New Zealand's a small country, 4 million people, 500,000 businesses. Australia's 10 times that. So what we're doing right now, what we've got devs back in Auckland doing right now is looking to migrate those databases across for us as well.
Fantastic. Thank you, Matt. Happened to be a very excellent outcome, but
yeah.
And this was like we also invited Matt so that you as the audience could also ask and infer on his insights and what he's experienced through. Because when Craig and I sat and were chatting with Matt earlier today, there were a lot of good lessons that they went through, and it's a very interesting journey they had. And more than the outcome, the way they got to the journey was really, really inspiring. And I'm sure you would stand to benefit from that as well. So thank you, Matt. And we'll open it up for questions as well. But we just want to recap. So Craig, you want to recap this part?
Yep. Yeah, so I mean,
Create
in the early
constraints.
stages, right? Like, yes, use constraints everywhere possible, says Sunil. No, get the basics right early on, right? Learn your tools, leverage the data types. As you grow, start to monitor your performance. Like, don't fall off the cliff. Don't hit that brick wall. Like, be watching that early on. When your cache hit ratio drops, when your I/O isn't sufficient, be prepared, right? And then now when you hit to that large scale, right, you now have that answer per Matt. Hey, Hyperscale Citus, now it's really as easy as dragging a slider to not have to worry about those things, as long as you're paying attention ahead of time.
Very nice. And then also, for us, it is about helping solve your problems. So we give you the tools and the capabilities that allows you to focus on your app. And if you are betting on Postgres because of its open source roots, because you like the database, because you like its rich functionality that is supporting, we are there to help you take it from a small database up to hyperscale database. And that's what we had to share today. We have about 4 minutes, and we wanted to do it on time so that we leave some good moment for Q&A. So at this time, we'll open it up for questions, either for Craig, myself, or even Matt.
No question is a good question as well.
There was a question there.
Yeah, it's literally seamless. Yeah, so how did we, yeah, it is literally seamless. Like there is no, like I had to check how many nodes were on today. Like so, like they could have whacked it an extra couple and it wouldn't have mattered. The sharding is all, probably hate me for saying this, but it's all, it's all magic black box stuff behind the scenes. Like it doesn't matter to me or the developers. We just, bang in an extra node and away we go. And even like, it was 4 weeks to take a database with, so it's probably not, like, it's about 80 to 100 gigs database, 300 gigs. It's a 300 gig database and move it across. And there was a lot of testing and nervousness on my part. We probably could have done it quicker, but we'd never used this before. So yeah, really seamless. Sorry? Yeah, we sharded the tables on users, so we got quite a defined set that we could do that on.
Yeah, and there's within the documentation you can find there's guidance on what are kind of the best practices around how do you shard which tables. There's multiple different table types supported. There's also like reference tables that are replicated to every single node. So if you got small lookup tables, you can join those. Those are then kept in sync with the two-phase commit under the covers. So you just interact with it like normal. So there's a multiple different table types, and then in terms of like what is the right shard key, the documentation walks you pretty well through that. And then if you have questions, reach out to us. Let us know. We're happy to help on kind of those data modeling things.
Yep. Yes.
So what's the impact if you go from say from 4 nodes to 8, and so it's going to reshard? What's the mechanically?
Yep. So mechanically, while that's reshuffling, you'll see some performance hit of 1 to 10%, pretty minimal. It's not heavily active and invasive, but when it is reshuffling, what we're doing is actually under the covers bringing up a new node, using streaming replication to stream that data in an online fashion, waiting till it's really, really close. We take a really, really short-lived lock, then we update the metadata, and all the new data is routed to that node. The end result is you go from 4 nodes to 8 nodes, like you've cut your query times in half, like you've doubled the performance typically. It is because nothing is perfectly linear in CS systems. It is very, very close to perfectly linear in terms of performance. Yep,
Yeah,
one
so
way back there.
if you can take a mic so that others can listen to your question as well, that would be highly appreciated.
Just curious in terms of query performance, how it compares to things like Impala.
How it compares with?
How does it compare with, sorry?
Impala, which is a Parquet file format you can read, and then you can do a bunch of SQLite queries on top of it.
Yeah, so it's a bit different, right? So there you're typically running queries on like an offline kind of data warehousing data store. With Hyperscale Citus, what we see is actually typically powering the direct end user application. So it is much more of like a transactional workload with analytical capabilities. So less data warehousing use cases and more of like an online application where you've got inserts, updates, deletes on this data, but you also need potentially analytical capabilities. So kind of typically serving 2 different use cases.
Cool.
All right.
All right, thank you so much.
Thank you.
And don't forget to fill out the survey and give your comments. Thank you so much.
Cheers.